calculus folks, let's go over a couple of very basic integrals using geometry, which is a thing I like. These are just gonna use a few really simple geometric formulas to tell us what the values of some definite integrals, some simple definite integrals should be, and in fact are. So the first one I want to look at is an integral from a to b, some interval a to b, of the function 1, the constant function 1. Well, let's see. If we were to graph the constant function 1, it would be a horizontal line here at height 1, right? And if we have an interval on the x-axis here from a to b, then the integral, the definite integral of this function, this constant function on that interval, will be the area of this rectangle right here. It's just a rectangle, right? What's its height? Its height is equal to 1 because this is a constant function at height 1. And what's its width? Well, its width is equal to b minus a, the difference between those, the distance between those two numbers on the x-axis. So this should just be equal to length times width, b minus a times 1, which is just b minus a. So that is a definite integral that we can memorize if we want. That's a very simple one. If you're integrating the function 1, you get a difference between the upper limit of integration and the lower limit of integration. In other words, the length with possibly a sign difference if the a and b are in the opposite order. But basically, it's the length of the interval. 2. Let's look at an integral, from 0 to b. We're specifically going to start at 0 this time, of the function x. And the reason I choose the function x is because if we start at 0, the function x gives us a triangle. So here's b, here's 0, here's the function y equals x right here. And this area, from 0 to b, is the area of a right triangle. What's its, area is 1/2 base times height, right? That's our area of a triangle formula. Well, the base is of length b, and the height is also of length b. The reason is because y equals x, so, horizontal distance and vertical distance will be equal to each other. X and y coordinates will be equal to each other. This would be the point b comma b, right? So this is going to be 1/2 b times b, which is 1/2 b squared, which is indeed what this integral should equal, 1/2 b squared. This is useful if you don't go from 0 to b. What you can do is you can go from 0 to a and 0 to b and then subtract one from the other. Like if you had an a here and you wanted to cut it off right there. Say you just want this area. What you can do is find the big triangle and then find the small triangle and then subtract one from the other and get just the leftover segment that you want. So you can, in integral terms, you can say something like the integral from a to b is going to be equal to the integral from 0 to b minus the integral from 0 to a. And you can, if you play around with this a little bit, you can justify this using the properties that I described in the previous video. So let's do one more. The third one, using geometry, is an integral from negative a to positive a of this function, this wacky function, the square root of a squared minus x squared. Now, what is this all about? Well, the square root of a squared minus x squared gives us the upper half of a circle of radius a. So this is a circle of radius a from negative a to positive a, and this is y equals the square root of a squared minus x squared. How do I know that's the upper half of a circle? Well, mess with this algebraically, and you can turn this into x squared plus y squared equals a squared. Now, the fact that this is the positive square root gives us the upper half. When you're solving for y, if you take the negative square root, you get the lower half of that circle. So that means that the integral from negative a to negative a to positive a should be the entirety of this this segment here, which is half of a circle. So this should be 1/2 of pi r squared. And what's the radius? R. Well, it's a, of course. So it's 1/2 pi a squared. And so that one can be adapted slightly. If you want to start at 0, you can take 1/4 of the circle. Okay. Starting anywhere else it makes it a little bit more difficult. but either going negative a to a or 0 to a gives you 1/4 of a circle, or give you half or a fourth of a circle. So all right, so there are three simple definite integrals using geometry. In the next page, I'm going to go ahead and do some examples and show you how to put this to use